Exercise Chapter 2, Number 6 claims that an interesting fact about vectors is that you can compute the squared norm of a vector as the dot product of that vector with itself. So first we have to check out this equation, and then just to convince ourselves that looking at the math, and then we confirm it empirically using Python. Okay, so this is actually a mistake. It really should be equation 2.7. So here is equation 2.7, where we define the norm of a vector. So the formula is the square root of the sum of all elements the sum of all squared elements. So now, imagine that we're computing the dot product between two vectors. Remember, the dot product is all the element-wise multiplications, and then we sum all of that together. So if we take the same vector, so vector v and vector v again, then element-wise multiplication is just squaring all the individual elements, and then we sum. Now, the one difference between the norm of a vector and the dot product of a vector with itself is this square root operation here. So the dot product doesn't involve a square root. So if we want the equivalence of the vector norm and the dot product with itself, we can either square the norm or take the square root of the dot product. And in the exercise, I said to square the dot product. Sorry, I meant to say in the exercise, I said the squared norm, and not the square root of the dot product. Okay, so here I just come up with some random numbers, 5 random numbers. Now, this is one of these cases where we do not need to worry about the orientation of the vector. So here, this is not a row vector or a column vector. This is just an orientationless NumPy array. And in this case, that's totally fine. We don't need this to have an orientation. In NumPy, you don't always need vectors to be to have a row or column orientation. Okay, anyway, so here I compute the dot product of C with itself. So that's going to give us, I call this the squared norm 1. And then I take the norm of C and square that. And basically, these are random numbers, so this result is going to be random. What we want to see is that these two numbers are the same. And they are the same up to like some ludicrous degree of precision. Again, just computer rounding errors. You don't need to worry about that. So I'm just running this code over and over. Obviously, the results are going to be different each time I run it because these are random numbers. Again, we want to confirm that the dot product of a vector with itself equals the squared norm of that vector.